Hello everyone. I hope you all are fine at your places. In the last video, we have talked about the waveguides. I have told you about the basics of guides, what is the implementation and how we use, why we use. I have told everything. Now, today, we will study about the parallel plane waveguide. So basically, it is the waveguide we can define as in the two parts. We can say that waveguide have a parallel plate waveguide or a rectangular waveguide. So we will study first about the parallel plane waveguide. Also we can say that parallel plate waveguide. Okay, so let's see in the parallel plane waveguide what happens actually. Wave is transmitting at the, see, this is a basic structure. Wave is transmitting at z direction and from the source to the destination it is falling. I've told you that in the waveguide what happened, there's a structure we call waveguide in which the wave travel. So here wave is traveling and the path it is following is the zigzag path. See, you can see that zigzag path it is following, and from the source it is following basically zigzag path. See here the space between the two conductors, this is the perfect conductors, infinite perfect conductors, or we can say that parallel plates. Spacing between them we have denoted as d. So this is the x-axis, this is z-axis. So it is where x equals to 0 we have started. We also sometimes call the source is feed point. Okay, so basically what happened, if I want EM wave to hit between plates and reach the destination plate without losing energy, we will study how we can transmit a wave without losing an energy. So before that, first of all I want to give you example about this parallel plane waveguide. See, this is our earth and this is the ionosphere. The main example we can say that duct propagating between earth and ionosphere. This is our ionosphere, and the wave always what happened, the wave always interact between earth and ionosphere like this. It follows always a zigzag path. Now we'll study some basic thing. Suppose I want EM wave to hit between the plates and reach the plate. How it is possible without losing energy? And we can say that distance have some certain amount, d is equals to m lambda upon 2 cos theta. This is nothing but it will satisfy the boundary conditions such that it will not lose any energy. So we can say that d is spacing between the two plates. I've told you about those two plates, and in between the wave will travel and follow the zigzag path. That m is nothing but a discrete number. So if the spacing between the plate d is m lambda by 2 cos theta, it will not lose any energy. Now what is m? As already I've told you, discrete number. M, if we put m equals to 1, then d will become lambda by 2 cos theta. If m equals to 2, then d become lambda by cos theta. Now what we can do now, if these cases will have, in these cases wave will not lose any energy. If we want to transmit the wave should not lose an energy. And how is this possible? If I twist the equation like this equation I will twist like this: cos theta equals to m lambda by 2d. Now what we are doing now, we are considering d should be a fixed point. Okay, and this way what we are doing now, I have a launching angle. We can say that this is a launching angle. If I fix the distance between the plate, I can launch with for the certain amount of m. As you know, m we can change it. Then you will get certain launching angles for different values of m, to which you can launch the wave will propagate along the waveguide and it will not lose energy. So what you have understood what I've told you. For the different values we can launch the different angle. Okay, now this, when you are launching for different values m, you will have different launching angles on the distance between the plate. This is for the different values m, you have different combination. In this way what we call this modal propagation. So one more thing, one more thing, you know that for a fixed d, the maximum value of cos goes to max 1. It means if you change the value of m to 1, 2, 3, 4, and so on, to you are keep changing, it means there will be a finite number or m exists for which the condition satisfied. So what was the condition? Wave can able to travel this. So finite m will be calculated as model propagation. We will have understood the basics of now plane wave propagation. What we have understood, let's conclude. Distance uh, between the two plate or spacing between the two plate should be fixed. If you are changing your distance, if you are changing your distance, it should be multiple of the or either you can change the launching angle such that we will not lose any energy and reach the destination point. So we have three things we have learned. In the next video we will learn the basic derivation criteria, and we will learn the different modes we have to use in this criteria. And thank you for watching this video.